In this video, I'm going to explain how the module system works in Rust. I'm going to use an analogy of parent and child to better explain this. And once it clicks, it sticks. So I'm going to give you 5 different scenarios which will cover all the different ways in which we can use the module system. So let's get started with the first one. Let's start with the rule number 1. Parent introduces their child to itself and other children only when the child allows it. So let's see how this rule comes into play. So first, in my main.rs file, I'm going to use the macro allow unused so that I don't get any warnings if I don't use any function or any enums or structs, if I don't use any components. Then I'm going to create an enum called direction, which just has left, right, top and bottom, different possible values for the enum. And then I'm going to create a function called direction sign, which takes an immutable reference to this enum and returns an arrow that points to in the direction. Okay. And in the main function, we're going to create a variable called direction, and then we're going to get the sign using this function, and then we're just going to print that sign. All right. If you go to the terminal and hit cargo run, you can see the output. Okay. So now what we'll do is we'll move this functionality into its own module. All right. So I created a file called direction.rs. Then I moved the enum and the function into this module. Now in the main.rs file, as per the rule, parent introduces their child to itself and other children. Now to load the direction.rs file, we can say mod direction. That is how we tell the compiler to load the direction.rs file. And then to use the enum and the direction sign function, we can say use direction, and inside the direction we can use the direction enum and the direction sign function. Okay. But you can see, if I scroll to the right, you can see these two are declared as private enum. Direction is declared as a private enum. So as per the rule, parent can only introduce a child if the child allows it, right? So if you go to the direction, we can see these two by default, all the components are private. So to make them public, you use the pub prefix before an enum, struct or function or any component. So once we set a pub prefix on the enum and the direction, you can see the error has gone away. Now if you go to the terminal and hit cargo run, you can see everything works fine. So that's it. Parent introduces their children to itself and other children if the children allows it. So that's how rule number 1 works. Now rule number 2 is children can have their own family. So right now, if you look at direction.rs, it's a single file, but we can move it into its own folder. So let's create a folder called direction and move direction.rs into its folder. And let's rename this file to mod.rs. So mod.rs is the parent in a child's family. So whenever you have folders in your Rust project, each folder would have a mod.rs file which acts like a parent in that family. All right. Now we don't have to make any changes to the main.rs file. So whenever you declare mod direction, it either looks for direction.rs file or mod.rs file inside the direction folder, which is already present, right? And we haven't created any siblings within the family direction. So right now all the functionality stays within the mod.rs file. So this should still work. So if I go to terminal and hit cargo run, we should see the result. Alright, rule number 3 is that siblings communicate with one another via their parent. So in JavaScript, you can create a file and have anonymous function, and you can import that file anywhere in the code, in any other file. But that is not how things work in Rust. In Rust, siblings cannot communicate with one another. They have to communicate either via their immediate parent or the global parent. So let's look at it. So first, let's convert direction into a regular child instead of a family. And I'm going to create another child called house, and we will use the enum direction in the other child, which is house. So I created another child called house.rs. Here I'm going to create an enum called room, which describes different rooms in the house. And then I'm going to have a function called room direction, which takes in the room and returns a default direction. So here I need to import the direction enum which is present in the other child direction. So how do we do that? So like I said earlier, communication between siblings always happens via the parent, the immediate parent or the global parent. So let's work with the global parent. So the main.rs file in the source folder, that is what we can call it as the global parent. So in this case, the immediate parent of house.rs is the main.rs. So this child will always look for the parent to access any other children, right? So in this case, the main.rs file already exposes the other child, which is direction. So we can import the enum direction in this child with the statement use create. So by saying use create, you can import any global modules that are exposed by the global parent main.rs. All right. So let's save this. Let's go back to main.rs and let's import this module. Let's extract the enum and the function room direction. Then let's create a variable called room, which is kitchen, and get the room direction and print that to the console. Now we can see an error that room doesn't implement the trait debug. So what's happening here is we are trying to print enums, but by default enums do not have a display trait implemented. So what we need to do is implement the derive debug trait on these enums to be able to use them with the printline macro. All right. So let's go to direction and implement this macro on the direction enum and also on the room enum. Save. Now let's go back to main.rs. Let's hit cargo run and you should see the result. So kitchen is on the left. So this is how siblings communicate with one another using the parent. So in this case, we have demonstrated how global siblings communicate, but we can have 4 different scenarios in this rule. A global child communicating with another global child, or a global child communicating with a local child. And using local and global, we can have 4 different combinations. So here we have demonstrated between 2 global child or children. So let's make one of them local and demonstrate a global child using a local, communicating with a local sibling. All right. Now let's look at a use case where a global child communicates with a local child. So what we're going to do is we'll change the direction.rs into its own family. And in this house.rs, we're going to keep it as a global child. And here we're going to have a function called opposite room. So that opposite room takes a room, and let's say the direction is left, right? So we look at what room is on the direction right and then return the living room. So if somebody passes, so if you pass kitchen to that function, it should return living room. Similarly, if you pass bedroom, it should return the opposite of top, which is bottom, which is the bathroom. All right. So let's implement that functionality. All right. So first let's convert direction into its own family. As you can see, I created direction as a folder and created mod.rs, which is the parent of that child. Okay. And then I'm going to create a new child within this family called turns.rs. So here we need the direction enum, and for now we're going to extract the direction enum from the global parent main.rs. So we can do that with use create. And then I'm going to create a function called opposite direction that takes an immutable reference to direction and returns the opposite direction. Now we need to allow this to be exported from the parent of this child, right? From the mod.rs file. So we can do that by saying pub mod turns. That's it. Now by saying pub mod turns, we are allowing this module to be used everywhere else in the code base. Okay. So now in the main.rs file, we're already importing direction. So this should already give us access to turn. So if we go to house.rs, which is another children, this is where we're going to import this now. So we can import that by saying use create direction, and inside the direction we have turns, we can see, and inside turns we have opposite direction. This is how we are communicating between a global child, which is house.rs, and a local child, which is turn.rs. Okay. Now let's create the opposite room function. And before that, I need a helper function which takes in the direction and returns the room. Here is the helper function that takes the direction and returns the room. And this need not be public. So we'll just keep it private for now. So we won't have the pub prefix before this function. And now let's create the opposite room function, which takes in a immutable reference to room and returns the opposite room. So first we'll get the room direction by passing the room, an immutable reference to room, and then we get the opposite direction using the opposite direction function that we imported here. And then we're going to get the opposite room by getting the direction of that room, and then we're going to return the opposite room. So it takes a room and returns the opposite room. That's what this function does. All right. So now in the main.rs, let's import the opposite room function, and then we're going to call it by passing the room variable that we created earlier, and then we're going to print the room opposite to it. So once we pass kitchen, we should get opposite of kitchen is, let's say, right, kitchen, opposite would be right, so room right would be living room. So once we pass kitchen, we should be getting living room. So let's hit cargo run and great. So living room is opposite to kitchen, so it works well. So this is how a global sibling can communicate with a local sibling. Now let's see how a local sibling can communicate with a global sibling. We kind of already demonstrated that in turns.rs in the way we imported this direction enum. So this direction enum is already being pulled from the main.rs file. So this is how it works, but I want to give another example to further solidify your understanding. All right. So we're going to create another sibling here and use and import rooms enum, which is present in the house sibling, and we'll create a function that we can then call from the main.rs file. So let's do that. So I'm going to create a child called checks.rs, and here we're going to have a function in checks.rs. We're going to create a function that takes two rooms and returns whether they're horizontal or not. So what do we mean by horizontal? So let's say we pass kitchen and living room. Then kitchen is on the left and living room is on the right. So they're on the same horizontal line. So that should return a true. And if they are not, let's say if we pass kitchen and bedroom or kitchen and kitchen, then they don't fall on the same line, so same horizontal plane, so that should return false. So this function, it takes in two rooms and returns a boolean value, true or false, depending on whether they are horizontal or not. Okay. So in checks.rs, first I'm going to import the direction from the global main.rs file, and then I'm going to import the room enum from the house sibling. So this is how we can import communicate between a local sibling, which is checks.rs, and the global sibling, which is house.rs. Okay. And then I'm also going to import the room direction function to get the direction of the room. And then I'm going to create a function called isHorizontal, which takes immutable reference to room 1 and to room. We need to pass room 1 and room 2, and it returns a boolean value. So first we'll get dir1, direction 2, and then we do a match. If it's left, right, or right and left, we return true. If not, we return false. So let's save that, and then we need to go to mod.rs file and make it available with the syntax pub mod checks. Now we are making it accessible across the code base. Then in the main.rs file, let's import isHorizontal function, and then create two variables, which are room 1 and room 2, and then just check if these two are horizontal and print them. Okay, so let's run this. As you can see, kitchen and living room are horizontal, which is true. Let's try with the different values, and it should return false. False. Perfect. So this is how a local sibling can communicate with a global sibling. Okay. Now let's see how to communicate between local siblings. So I'm not going to create any new functions here, but I'll just demonstrate how we can do that. So let's say checks.rs wants to communicate with turns.rs, and you want to import opposite direction in checks.rs. So you can do that with the command use super. You can use the prefix super instead of create to import local, to communicate between local siblings. So again, it goes through parent. So if the parent for checks.rs is mod.rs, where we are already making turns available, right? So that allows checks to import all the public functions in this module. So we can say super, then turns, and then opposite direction. So that is how you import or communicate between local siblings using the local parent, which is mod.rs. Okay. So that's the difference between create and super. Create, it is used to import from the global parent, which is main.rs, whereas super is used to import from the local parent, which is the mod.rs file within that folder. As always, child will control what is allowed to be exported with this public with this pub keyword, whereas parent is still the one that facilitates this communication. Now let's look at a scenario where you want to obfuscate the complexity within a child family. So what do I mean by that? So let's say in the direction file, you have checks and turns, which are two modules, sub-modules within the direction module. And there can be 10 different files or 20 different files that the parent need not know, right? So let's say in this case, right, the way we're importing horizontal is horizontal. First we're looking into the direction module and then into the checks module, then we're getting the is horizontal function. What if we don't care which submodule this function is present in? I just want to have access to all the functions, and I don't need to worry, as a parent, I don't need to worry about how the files are structured within a child family. So we can do that by just saying in the local, in the child family, go to the mod.rs file and just say public use, let's say checks :*. Okay. Then if you go back to main.rs, instead of importing it from the checks submodule, you can directly import from the direction module. So if I go to direction sign and say is, you can see now is horizontal is available. Let me show you that once again. So if I go back to mods.rs and if I, let's say I comment out this code, if I go to main.rs, now I won't be able to import this file because it's not made available. But if I do pub use checks.rs, so what this does is it takes all the functions, everything that is public within this checks.rs file, and makes it available directly from the parent level, so that the parent file need not worry about the complexity or file tree structure within the module. So if you go back here and go to is horizontal, see this is now available directly from the direction module and not from the checks submodule. So this is how you can make all the all the functions, all the components within all your submodules accessible directly from the parent file. But there is a drawback with this approach. The drawback is you have to be cognizant of the file names or all the files that you create within the child family. So let's say in this checks.rs, right, you have is horizontal function. Now you have to make sure that you don't have this function anywhere else in any other submodule. If you do that, it's going to create a problem. So let's create a new one, right? Let's say so in the clock.rs file, I'll create a function with the same name is horizontal, which is already present in checks.rs. And if you go back to mod.rs and export this submodule, if you go back to the main.rs, you can see there is an error that is horizontal is ambiguous because there are multiple glob imports. So so having the same name will create a conflict, and the developer has to make sure that you don't reuse the same name. Lastly, you can have nicknames to shorten the import path. For example, I will have a nickname for room so that I can directly import room enum instead of having to go to house and then the room. So to create a nickname, you can use the syntax use house, public use house and room. So if we do it, so if we define this in the main.rs file, we have created a nickname for room. So you're getting this error because it's already imported here. I'll just delete that. And now if you say public use house and room, we are creating a nickname that allows us to directly import room. So if you go to checks.rs, so here instead of when we're importing room, we can just directly, I'll just comment it out and show you how this works. You can say use create, and you see room is available. So by having a nickname in the master parent file, you can directly import that particular component without having to drill down into the modules. But again, the same drawback that we discussed earlier also applies in this case. Now that you created a nickname called room, you should be careful not to reuse this name again to avoid conflict. One real world use case for having nicknames is, let's say you want to have a dedicated error module that you want to use across the code base. Then you can create a nickname in the master main.rs, the main parent file, and then you can use this error module across your code base so that you can have a centralized error management. Finally, all the concepts that I discussed in the video I created a cheat sheet to make it easy for you to go through or quickly summarize these concepts. And this markdown file is available on my GitHub account for free, and I'll leave a link to this in the description box. That's it for this video. I hope you now have a better understanding of how the module system works in Rust. And let me know your thoughts or suggestions in the comment section, and I will talk to you in the next one. Bye.